My dear students, in continuation of our mark scoring videos for the junior intermediate, we are going to discuss three important 4 marks questions. That means short answer questions from the 10th chapter called Mechanical Properties of Solids. So there are only 3 questions. There are 4 questions in which 3 are very important. Out of those 3 questions, only one question is foremost important. Is this clear? But I am here to teach you 3 questions. One is define stress and explain the types of stress. This is one question. And the second question is define strain and explain the types of strain. Next question is describe the behavior of a wire under gradually increasing load. So this question is very important. So out of 10 papers, you will find this question in 8 papers. So the probability of getting this question is very high. So I'll go in details regarding all these 3 questions. Let me introduce the chapter and a few topics. So the name of the chapter is Mechanical Properties of Solids. Mechanical Properties of Solids. In this, we discuss only 2 things. One is elasticity and plasticity. So antonym of elasticity is plasticity and other way around. So what is the difference between the property called elasticity and plasticity? I will try to explain. So elasticity is something can be stretched. When you leave it, that means when you remove the force, it will come back to its original shape and size. So that is elasticity. Whereas plasticity, you cannot stretch it. For example, a rubber band, you cannot stretch it. Even if you want to stretch it by applying a huge force, it will break into pieces, but it won't stretch. The best example for this is you take a rubber ball, or people use stress ball. So what we do, we apply force with our fingers. So the shape and size of the stress ball will change. So because of application of external force. So previously this was the rubber ball. Now after the application of force, it has this shape and size. So I am bringing a change in the shape and size. So those forces, that means these forces, are called deforming forces. Deforming forces are those forces which bring some change. They bring some deformation in that object. So suppose you have a sponge in your hand, just you apply the force, it will come to a smaller size and it will lose its original shape and size. So this force, the force which is being applied by my hand, is called the deforming force. As soon as I remove the deforming force, what happens? So there will be forces acting within the object to bring back its shape and size. The forces which are acting within the object are called restoring forces. So when restoring forces are equal to deforming forces, then the object will regain its original shape and size. So what I mean to say is, in almost all our definitions, you can replace deforming forces by restoring forces. Both are same. Suppose you have a car and you had unfortunately you had an head-on collision with something else. What happens to the shape and size of the car? It will change. So suppose a car had an head-on collision with another car. So because of that, there will be some change in the shape of the car. So what is happening? After the removal of force, that means after the accident, the shape of the car will not regain to its previous shape. That means the restoring forces are not sufficient to bring back the size of the shape of the car to its original shape or size. Right. So in almost all elastic cases, we consider that deforming forces are nothing but restoring forces. So how do you define elasticity? No need to remember all these things, but we are supposed to know. The property of the body by virtue of which it tends to regain its original shape and size on the removal of deforming forces is called elasticity. The ability of the object to regain its original shape and size after the removal of external force. Is this clear? That is called elasticity. The inability of the object to regain its original shape and size is called plasticity. Just now I told you, this elasticity and plasticity are antonyms to each other. The object which shows this elasticity is called as an elastic object. The one which shows the plasticity is called as plastic object. Is this clear? Right. Now, which is the best 100% elastic and which is the best or 100% plastic? So, you don't have 100% elastic object in the nature and you don't have 100% plastic object in the nature. So, you can't have ideal elasticity situation or ideal plasticity situation. Now, the best elastic object in the nature is considered as quartz crystal. Quartz is considered as the best elastic object, not the 100% elastic object. Now, the best plastic object is considered as the putty that we use to fix the glass in the metal frame of a window. So, we put a M-seal type material here. So, once you fix it, it will remain like that only. M-seal is the best plastic object, right? So, even dough also, pindi mudda is the best. You make a chapati, it won't regain its original spherical shape. That is the reason why that is plastic. Is this clear? So, quartz is the best elastic object. That is the reason why in your wristwatches and modern wall clocks, we use quartz. That is the reason why they are called Ajanta Citizen quartz watches. So, we are not going into the details, right? Now, there are two words that you have to learn in this chapter. One is called stress, the other one is called strain. So, one 4 marks question is related to stress and another 4 marks question is related to strain. What do you mean by stress? Suppose this is the ball on which I am applying the force. I am applying the force throughout its area, that is the outer surface. The force acting per unit area is called as stress. So, just now I told you, force is the deforming force that you are applying and the forces that are developed within the object are called the restoring forces. So, you can define stress as the restoring force per unit area or the deforming force per unit area. So, stress is nothing but pressure. Stress is nothing but pressure, you have to remember. Force by area. So, units are Newton per meter square. Newton per meter square is nothing but Pascal. That is stress. Now, what do you mean by strain? Strain is the change. Suppose this was the original volume of the ball. Now, I squeezed it. So, its volume decreased to a smaller value. Now, what is the difference between these two? That is delta V. Delta V is V1 minus V2. V1 is the initial volume, V2 is the final volume. Right. So, the change in the volume compared with the original volume is called volumetric strain. Suppose you have a rubber band. This is the rubber band. So, you are applying some force and you are trying to stretch it. You are applying some force. So, because of this force, its length increased. So, what is the change in the length? Delta L. What is its original length? L. So, delta L by L is called strain. So, strain is the ratio of same quantities. That is the reason why it has no units and dimensions. So stress is the restoring force or deforming force acting per unit area. The strain is the change in shape per original shape. Change in the dimension per original dimension. Dimension can be length, dimension can be area, dimension can be volume. Is this clear? Its formula is F by A, its formula is delta L by A, delta L by L. That is not the formula, this is called longitudinal strain that we will discuss. It has units of Newton per meter square or Pascal. For this there are no units, right? So there are three questions as I told you. One question is on stress and another question is on strain, right? Now there are three types of stress. One is called longitudinal stress. The first one is called longitudinal stress. It is also called as tensile stress. What do you mean by longitudinal stress? You take something, let us say this is a cylindrical object. I am applying force downwards. Because of this, its length increased and its area of cross section decreased. So it is undergoing change in its length. So I am applying force such that its length is changing. That is the reason why it is called longitudinal stress. So how do you define longitudinal stress? So force acting per unit area. Here area is this. So it can be written as F by pi r square, where r is the radius of this cylindrical object. Right? So longitudinal stress is applied such that its length is being increased. Right? Next, second type of stress is called bulk stress or volume stress. So what do you mean by bulk stress? Just now I gave the example of the ball, same ball, you apply force. So when you apply force, its volume decreases. I am applying force such that there is a change in its volume. So bulk means whole object. Its volume is changing. So this force divided by the surface area of the ball is called as bulk stress. It is also called as volume stress. Now, how do you define strain in this case? So just now I defined delta V by V. Delta V is change in the volume, V is the original volume. Here volume is decreased, so I have to put negative sign here. Is this clear? Right. Now another one is shearing stress or tangential stress. What does it mean? Suppose you have a very big book like Bhagavad Gita or something, or Mahabharata or something, having number of pages, big in size. In olden days, we used to have what do you call dictionaries also. I had a C.P. Brown dictionary which was this much thick in size. So I placed it on the table. Now I am applying a force in this way on the upper surface. So I am trying to push the upper cover of this dictionary. So what happens? The size of the dictionary will become like this. The shape of the dictionary will become like this. So this force, which is bringing the lateral deformation, is called shearing stress. So how do you define shearing stress? Shearing stress, a force tending to cause deformation of material by slippage along a plane or planes parallel to the imposed stress. So I am applying force parallel to these layers. So how do you define strain? The shearing strain is equal to this theta. How much the lateral side deformed is indicated by the theta. So theta, you can take tan theta. So the theta value is delta x by L, where L is the length of this size or this side. Is this clear? So this is called shearing stress and strain is called shearing strain. So these are the three types of stress and strain. There is a formula, there is a law called Hooke's law in elasticity. You should know all these fundamentals. Suppose you have a rubber band. So if I want to stretch it to this extent, I have to apply less force. If I want to stretch it to this extent, I have to apply more force. So force in our terminology is stress. Elongation in our terminology is strain. So strain is the change, stress is the cause. So stress is the cause, strain is the effect. Is this clear? Right. So from this it is clear that strain is directly proportional to stress. If you apply more stress, there will be more strain. So since it is being elongated, if I apply more force, it has to break. So once I remove the forces, it should come to its original position, original shape. So I am not supposed to break it. So that limit is called elastic limit. So I am not supposed to go beyond this elastic limit. So how do you define stress? Within the elastic limit, strain in a solid is directly proportional to the applied stress. So strain is directly proportional to stress. So whenever there is a proportionality relationship, we will put a constant. So I will put a constant. Strain is equal to some constant 1 by E times stress. So now I can write E is equal to stress by strain. So this proportionality constant is called modulus of elasticity. So how many types of stress and how many types of strain? We had 3 types. So moduli of elasticity will also be of 3 types. The first one related to longitudinal. The second one is volume. The third one is related to shearing. So you will have 3 types of moduli of elasticity. Is this clear? Right. No need to read all these things. The first one related to longitudinal one is called Young's modulus. Young's modulus is indicated by capital Y. So this is tensile stress by tensile strain. That means longitudinal stress divided by longitudinal strain. So this can be written as F by A divided by delta L by A. Is this clear? Right. Now shear modulus is indicated by capital G. In some books it will be different. No need to worry. So shear stress by shear strain. Bulk modulus, volumetric stress divided by volumetric strain. Right. Now let us go into our scoring part. That is, we want marks only, but you should have some idea. Without having idea, if you by heart the answer, you can't write the total answer. In between somewhere you will struck. Is this clear? Right. Define stress and explain the types of stress. So how do you define stress? Stress is nothing but deforming force or restoring force acting per unit area. That's it. So how do you write? Stress is equal to, you can write it as a ratio, that is restoring force divided by area. That's all. If you write this much, you will get 1 mark. If just write the formula, you will be given 1 mark. And explain the types of stress. We discussed 3 types of stress. One is longitudinal stress or tensile stress. So longitudinal stress is equal to, so how do you define? So force by area. So if you want, you can draw a vertical cylinder. I am applying force such that I want to increase its length. So this force is trying to increase its length, and this force is being acting on this area. So this ratio is called longitudinal stress. The second one is volume stress. So it is bringing change in the volume. So for this also F by A. If you want, you can draw a diagram of a ball. You are applying force. This is the force. the resultant force. Because of this, its volume is decreased and the area is the surface area. And the third one is shearing stress. So you are applying force on something such that you are applying tangentially to the object. So what is happening to the layers of this object? So because of the application of this tangential force, I am pushing these plates or the planes, so it is being deformed like this. So this force acting on this surface is nothing but shearing stress. So for all definitions, force divided by area. That's it. You will be given 4 marks. So 3 lines for this, 1 line for this, write 4 lines, get 4 marks. And this is related to strain. Define strain and explain the types of strains. I told you strain is equal to change in the dimension divided by original dimension. That's it. So in the case of longitudinal strain, the first definition, longitudinal strain is equal to change in the length divided by original length or initial length. So how do you write? Very simple, delta L divided by L. The second one, if you want, you can draw a small diagram. Second one, volumetric strain or bulk strain. So change in the volume divided by initial or original value. So how do you write? Delta V by V. If the volume is being decreased, you have to put negative. If the volume is being increased, how do you increase the volume? You take a football and you are pumping some air into it. So its size increases. In that case, delta V is positive. If you have a ball in your hand and you are trying to squeeze it, in that case, its volume is decreasing. So no need to consider this negative and all. You will be given marks, that's all. And the third one is shearing strain that we already discussed. So it is nothing but theta. You draw the diagram. This is the initial one. So because of the application of the force, so this side, this lateral side displaced by an angle theta and this theta. So this theta is nothing but how much it moved, delta x, and the lateral dimension is L, that is delta x by L. Is this clear? So this is the third strain. This question is very, very important. 100% you are going to get this question in the exam. The other two are not that much important. Right. Describe the behavior of a wire under gradually increasing load. Load means weight. Weight means you are applying force. So try to understand this. Suppose there is a wire. This is a cylindrical wire. Now what I am doing, I am applying some weights to one of its, to the lower end, the upper end is fixed. So what is happening? When I increase the weights, if I put more number of weights, that means when I increase the load, what is happening? Its length is increasing because it is being stretched, being elongated. So at microscopic level, its length is increasing. Once I remove the weights, once again, it gains the original length. Suppose it is increasing. So I am so greedy that I am putting lot of weights. What happens? It becomes, this thick wire will become thinner. At some extent, it will break. So I am plotting a graph between two things. One is stress, the other one is strain. So stress is nothing but application of weights. increasing the force. Strain is nothing but change in the length. So I am plotting a graph between these two. So I am applying weights, that means applying force, then removing, applying, removing. Is it coming back to its original length or shape or size or not, that I am checking. Right. So the graph will be like this. So, but you have to imagine this diagram, then you have to draw this. Without imagining, without having the proper knowledge of this imagination, you can't do this. So this is on x-axis I am taking strain, and on x-axis I am taking stress. So stress is the applied load, strain is the change that what you see in the wire. Is this clear? So this you have to keep in your mind. So there will be some three segments. Suppose you increase the stress, then strain also increases. Hooke's law is followed. That means strain is directly proportional to stress. That means Y is in the textbook you will find stress is directly proportional to strain. Both are correct, but actually the other way around is correct. So stress is being taken on y-axis. So y is proportional to x. You will put a constant. Y is equal to mx. In mathematics is a straight line passing through the origin, making an angle of 45 degrees. That is the equation for y is equal to mx. So in the beginning, when I increase the force, the length also in the proportion to the weights, the length increases. So to some extent, so I will get a straight line making an angle 45 degrees. So after that, if I increase, the graph will not be a linear one, it will be a curved one. So up to some extent, let us say this is A, this is B. Up to A, from O to A, Hooke's law is followed. That means up to A, this and this are proportional to each other. So at B, even if I remove the weights, attached to this, it is gaining its original shape and size. That means up to here, it can come back to O. So come back to O means delta L is 0. Delta L is 0 means the initial length. Is this clear? Right. So this is very, 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 very important. This question you are going to get it in the exam, damn sure. Right. So after B, at some point it will start yielding. So that I will show you in this graph. This is colorful, more colorful. So I am plotting a graph between strain and stress. Strain on y-axis, stress on x-axis, strain on x-axis, stress on y-axis. So initially you will get a straight line. This graph may not be same for all materials, remember. It's a generalized graph. If you have some metal, or if you have some rubber band, or if you have some other material, for all materials you won't get the same graph. This is a generalized graph. So in the initial, you have y is equal to mx graph. So from O to A, this is called proportional limit or proportionality limit. So up to A, Hooke's law is followed. So after A, at some point, you have elastic limit. That means if you remove the weights, you will come back to its original length. That means elongation delta L is 0. You can come back to its original length. But here it is not a straight line, it is curved, means from A to B, Hooke's law is not followed. From A to B, Hooke's law is not followed. But from O to A, Hooke's law is followed. Now, after B, if you increase, even if you apply less stress, see, that means there is no much change. Little amount of weight is increased. Very small amount of weight is increased, but there is a strain. So after point B, you will see a permanent elongation in the wire. If I remove the weights, it won't come back to its original length. So there is a deformation, and that deformation is permanent. It is permanently elongated. Is this clear? So even if I remove the weights at this point, instead of coming back to original length, there is some increase. This increase is delta L. This is permanent. So this indicates permanent elongation. So that is the reason why this point C is called permanent set. So this O, let us put some C prime. So OC prime is permanent elongation. So after C, if you increase further, the wire behaves like a liquid, semi-solid. So its thickness gradually decreases. At some point, it will break. So after B, the wire is losing its solid property and it is going to behave as if it is some semi-solid. Its thickness is decreasing. Even if you don't increase the weights, because of its previous weights, its thickness decreases, its radius decreases. So at some point, it will break. Its thickness is decreasing. So at point D, this is called breaking stress. So if you write O, A, B, C, D, that is enough. So what is happening? After C, it is having plasticity. It is going beyond its behavior of elasticity. So if you write this much, if you draw the graph and explain OA, first you explain about OA region, that is called proportionality limit. Next one is AB, that is called elastic limit or yielding point. Next BC is related to permanent elongation. Next D is called breaking stress. If you write these 4 points, you will be given 4 marks. So in another video, I will be dealing with few more important questions. Thank you.